Okay, this is the review for the Trigonometry 2 final exam, second semester. This is the end. My only friend. The end.
Stop it.
Start playing Jim Morrison indoors. Anyway. Alright, so if you have your calculator, you could probably do like 90% of this test without even trying. Alright, so the first thing I'm going to do, this says which angle measure could be value of inverse cosine of that number. Now, you got to be able to read this. You have to know what you're talking about. So the very first thing, what do I have to check for this problem here? Degrees, right? Because all my answers are in degrees, I need to actually put it in. My calculator's got to be in degrees. For this test, you have to know when to switch for different modes. You have to know when to change it. So let's go through and do this. So please, someone right now, calculator that.
What is it?
2063.
Why am I looking up there? I just put it right here.
Is it 78?
78.
Okay. Let me see if I can pull this up too. Documents.
And do we need to change it from rectangular back to real?
So, trig inverse cosine 0.2063. There you go. You're not going to have to change the real and all that yet. I'm going to have your calculator set up in that mode in the first place. So your calculator is going to start in that mode, and then you have to know when to change it. So we changed it when we started doing complex numbers, imaginaries, i's.
All the way at the end.
Yeah, so anyway, so this one is 78. The diagram shows the graph of the invertible part of the function sine x. Anyway, something. Based upon this graph, what is the domain of the inverse?
That's on our little thingy,
It's on your little thingy.
reference sheet.
Here it is right here. Let's see if I could zoom this.
Wow.
Magic.
Yep.
So,
Inverse sine, domain of the inverse is from -1 to 1.
so B.
So for this right here, -1 to 1, my answer is going to be B. You could also see it on the graph if you could make it out. You could probably see it better on yours. I kind of blew it up so we could. You guys got the 2 columns on your paper. I tried to make it big enough for, 1 problem per slide here. So if you can kind of see that, that's 1 there, that's -1 there. So. What is arc sine 1/2? Okay, so
Okay.
yeah, you can calculate that. So it says sine, and then arc sine
Half.
of 1/2. 0.5, the answer is 1/2, right?
Same with this.
What is value of tan, arc tan, or I'm sorry, arc cosine, sorry. Negative right 2/2.
-1.
-1? Do you guys agree?
Yeah.
Is everyone following? Everyone got it? Let me know if I'm going too fast on this. What is the value of sine quantity arcsine plus arctan, all that, right?
A.
What would I do?
Plug it in.
Plug it in the calculator again. Almost like there is a common theme to all this. I'll give you a moment to plug it in so you could actually, because if you don't know how to plug it in right, then you're gonna have issues. You can't adjust that size. What did we come up with? A?
What?
I missed. I'm sorry.
I
Wow.
was like, wait, what?
You're not even
I'm
winning.
telling you, I am not here this morning. I am so much pain right now. So. What is the solution of the equation of rad 3 times tangent theta minus 1? My intervals from 0 to 2 pi. Now, I taught you guys how to do this. I did.
Oh, this is where you turn it into an inverse.
No, it's not.
Oh.
Okay, I taught you guys how to do this.
Do you get the tangent by
No, anyone recall this one?
that was a long time ago.
Yes, it was a long time ago. Huh? You could. A little bit easier than that, though. Actually, a lot easier than that.
They flipped them?
Nope. Come on, you guys. You were all here.
Were we?
Huh?
Doesn't have something to do with numbers.
It could, but it's not what I'm looking for. Bees
The
thing?
bees
No.
thing?
What are you calling the bees?
Movie.
Yeah, quadratic.
No.
Just
Even
tell
easier
us,
than that.
We're gonna be sitting here all day if not.
What unit was this? Unified?
One.
One?
Just kidding. The calculator?
Oh, and this graphing thing.
Oh my god. Wow.
I'm gonna kill myself.
And instead of theta, you used S. I remember.
Oh, and you forced degree it. Oh, I remember.
Wow, man. See, you guys remember this.
You could have given us a unit.
Okay. I entered it. What do I gotta do?
Fix the graph.
Fix the graph.
Oh,
Thank you.
just
The
change
window.
Change the window.
There you go.
What's my window supposed to be?
0 to
0
pi?
to
Pi? 2 pi?
well 2 pi since our answers are in radian.
Hold on. Let's check the thing. It says my intervals from 0 to 2 pi,
Yeah.
but what do I have to do instead?
0 to 360.
There we go, 0 to 360. So, let's go menu, window,
Wow.
settings, 0, 360. Okay, auto, X scale, all that.
There's 2, so now you have to find your zeros.
Okay, so now it's on the graph, right?
Yeah.
Okay, so I'm gonna have 2 places in which that my answer is equal to 0, right?
Yes.
So I'm gonna have 2 answers for this.
1.
So I have to solve for my zeros. So how do I do that from here? Can someone?
You hit menu,
Menu.
Analyze.
number
Analyze.
6.
6 or 7?
6.
6,
0.
0.
And then drag it across wherever it's crossing the x-axis.
You actually press 1, not 0.
30 and 2.
But you have to transform it back to radian.
You gotta do
Okay,
it.
so that one's 210.
You gotta do it again.
Pi over 6.
I'm getting it. Sorry, trying to be fancy here.
Don't be fancy.
There you go.
There you go. So I have 30 and 210, right? So let's go back to my thing. So my answers are going to be 30 degrees and 210 degrees.
Pi over 6 and 7 pi over 6.
Yes.
How did you get those?
The
You
unit
could have asked me
circle.
for his.
Well,
No,
I
for that,
converted
no.
it.
Okay, so these just so happen to be on my unit circle, but you're gonna get a lot that's not on your unit circle, so we're gonna do a conversion, right? So to convert degrees, it's gonna be
Divide by
30 degrees, right?
Over 1.
Times
Pi over 180 over
180, pi over 180, right? So that's gonna give me pi over 6. Do the same thing again, 210 degrees times pi over 180. So it comes out to be
7 pi over 6.
7 pi over 6. There we go. So my answer has to be C. See, now that you remember this, now does it come back? State the domain and range of inverse secant x. Okay, so where would I find it?
In your little
Your reference
reference
sheet.
sheet.
Inverse secant x, it's this one right here, right? Domain from here, there, I can't equal to pi over 2. And it is going to be D. So it is, the answer is actually on the test. So if you pay attention, the answer is actually on your test. I give you the answer. You just have to know where it's at. What is solution of the equation 2 sine theta equals sine theta over interval 0 to 360? Step 1. This is different than the previous one. So step 1, what should I do?
You have to get them.
To get further down the
Excellent, very good. Equal to 0. I'm going to go equal to 0 on this one. So I'm going to subtract sine theta from both sides. So sine 2 theta minus sine theta equals 0, right?
Now you're able to.
Now I could plug this into the calculator, right? Okay, and when you do this, you plug this in. Please make sure you do not forget. You have to force degrees. Okay? Especially if I wasn't here for any of this, I'm paying attention, not playing with my phone right now, because I would be very salty. All right. So let's go back to the calculator. Ah.
4.
Dang it. Yeah, why do I keep messing this up? So sine of 2 theta x forced degrees minus sine of x degrees. Is that right? Okay, hope so.
Do we have to change the one that?
I do at least, because when I was messing with the board, I messed up the thing. So I'm gonna change it because I messed up mine. Window 0 360. There we go. Now, how many answers should I have here?
4,
4.
Let's see. I have 1 here.
0.
1, 2, 3, 4. can 360 be one of my answers?
No.
Yes.
Yes or no?
No.
Let's look at this one right here. If I'm looking, this says bracket 0, comma 360 parentheses. Remember, the parentheses says it cannot be equal to that. So bracket says yes, parentheses says no. So right here, now how do I test to see if it's going to be at 0? Remember, I have to go somewhere to the left of this.
You have to go right by it and then hit negative.
Okay, so now let's see. So I'm going to do the same thing. So analyze 0. So I'm just going to hit the number, and my line automatically jumps. So I'm going to go like -2. Enter, and then there we go. So I get it here. You don't actually have to move it every time. You could guess to where it's at. So I knew that it should be at 0. So I just put numbers around 0. Okay, and the next one. So menu, analyze 0, 60. Last one. Okay, my answers are 0, 60, 180, and 300. 0, 60, 180, and 300. Is that D? I think so. All right. Questions? I'm hoping you guys are actually going through and plugging this in as we're going, because this is the key thing to this. What solution of the equation 2 cosine squared theta equals 2? First thing again, what should I do? Equal to 0. So I'm going to be entering 2 cosine squared minus 2 equals 0. And again, my window is from 0 to 360. Okay, what was the function again?
2 cosine.
Thank you, 2 cosine x. Remember, the square has to go on the outside. And then it goes square, has to go like that. And then minus 2, right? Like that? Okay. All right, how many answers does this one have? 2. You know, my calculator settings were already set up for it to actually give me these answers already. But what did I say if I get something weird like this thing right here?
It's basically 0.
It's basically 0, because this is 1.16 times 10 to the negative 10. That means that is 116 with 10 zeros in front of that. So it's a decimal point, 10 zeros. It's a very, very small number. It's implying that it is 0. So my two answers here are going to be 0 and 180. My answer is B. Questions, concerns? Okay, let's keep going. What are the solutions of the equation here? This is another good one right here. This one is already equal to 0. It's already equal to 0. So I want you guys plugging this one in right now, please.
Put your feet in.
Yeah.
I'm like waving.
it's gonna be equivalent to that, that's
Yeah.
all you're looking for.
So you see which one you
Mhm.
choose. But it has to be in radian, right?
Yeah.
Okay.
Let's see. 3 cotangent squared, 3 cotangent. Is it minus cotangent?
Yes.
3 cotangent, thank you. And minus 1.
Mm-hmm.
There we go. Do we have the same interval on this one?
Yes.
Let's see, 0 to 360, yeah, okay. All right, let's see, how many answers should I have here?
4.
4. My calculator is already spitting out some of the other ones because I already had it set up on the previous to find zeros. And I'm just missing, for mine, I'm just missing this one right here. So I'm just missing that one, so I need to go ahead and still find that one. Analyze, 0. 38.4, 105, 218, 285. Four, 105, 218. There it is right there. Now, do you guys know why it doesn't have decimals on those? It rounds it. It rounds it. It only gives you the 3 digits. So it rounds it off. So only if it's double digit will it give you the next decimal right there. But if that's just using it from this screen. If you want to find it with like all the decimals, there's another way of doing it. But this one's quicker. You already know that. If you know that it's going to estimate it or it's going to round it at that point, you know what? You're looking for the numbers that are right there. There we go. What a solution of this equation right here. So class.
Yes.
Okay. Oh, that was, you guys, come on, at least try. What's the first thing I should do?
Equal it to 0.
Equal to 0, right? Equal it to 0. So CSC squared theta minus 2 cotangent theta equals 0. Now, what does it mean about my interval this time? It says 0 to 2 pi. What does that mean? Your answer is going to be a radian. Does that change anything that I'm doing?
No.
It doesn't. Because you're using the calculator, you have to do it like this every time. You have to do it in a degree. And when you get your degree answer, you convert that back to radian. So, let's go ahead and do that. CSE squared. 2 That's weird. There we go. What did it start off with? Was it just CSC squared?
Yes.
CSC. What goes next?
Minus 2
Thank you. Minus 2 cotangent. Was that it? Okay. Dang it.
Technology.
I know, technology. At least it's still working, but my board just stopped, so I could still hit it from here. There we go. All right, so how many answers do I have here?
2.
2. 2 is the number. Anyway. So 45 and 225. So let's go back here. So 45 degrees is going to be my pi over 4. And 225 is going to be 5 pi?
Yep.
Yeah. 5 pi over 4. That's an ugly 5 pi. There we go. So my answer. Which has a value equivalent to the value of sine of negative pi over 3. So, what could I do there? Plug it in your calculator and approximate each one. We're looking for the same value.
Oh, you're right.
And what's special about this one? Go ahead. What's special about this one? What's different than what we were doing for all the rest?
Radian.
Thank you. Radian. So at this point right here, you have to look at it, you have to read it, you have to see. Calculator has to be in radian to be able to do this correctly. I'm going to try and do this one without. So, let me see. If I have my unit circle here, negative pi over 3 is there. So that would be 1/2 and negative rad 3 over 2. And then, so at positive pi over 3, that's going to be a 1/2 a rad 3 over 2. So a negative, so cosine is this number and sine is this number. So I'm trying to match this one. So cosine, no. Cosine, no. Sine, negative sine pi over 3. So sine pi over 3 is this right here, but it's opposite, so it has to be C. And sine pi over 3 would be a positive of, so. After you guys did all your math, did you already come up with the same answer? Yeah. So, unless you know the unit circle and actually like your unit circle, which at this current moment right now, I'm just hoping you guys will, do this much to pass. So. If you begin with the Pythagorean identity, sine squared plus cosine squared is equal to 1. You divide both sides by cosine squared, which identity would you be developing? So let's see, sine is, remember that's y squared plus x squared equals 1. So if it's y squared divided by x squared plus x squared over x squared equals 1 over x squared, right? Okay, so y over x gives me what? Tangent. So this is tangent squared, right? Theta's. Plus x squared over x squared. 1 equals 1 over x squared. Secant squared. So my answer is it the first one? Yeah. Okay.
Are you giving the scratch paper on this?
Would you like some scratch paper? Okay. Do you want some scratch paper like graphs and stuff on it?
No.
Okay. Do you want just plain blank paper?
Yeah.
Okay, I could do that. 14. What's simplification of the expression cotangent theta times sine theta? Now, let's do the xy thing. Cotangent is what over what? X over y. So it's x over y times, what is sine? But this one's using identities. It's not r. My r is always 1 when I'm using identities, remember? So this is y over 1, isn't it? Now, use a little bit of algebra. What's going to happen? Y's canceled and you're left with X over 1, and X over 1 is? Yes. Go ahead. 15. This one's use identities to write expression in a single format of X. Now, this one is, it is an identity. It's either going to be a sum or difference identity. Okay, so please flip all the way back to the front and look to see at your sum and difference identities. So it goes sine, cosine, minus. This one it? No, it's the other one. There we go. So, this problem, as it read, was sine, cosine, and then a minus sign, right? So let's see, which one goes sine, cosine, and a minus sign? It's a difference, right? It's going to be a difference of what? A sign, right? It's going to be a difference of sign. So it's going to be this here. So it goes sine, cosine, minus sign, right? That's how I identify which identity is being used. If you guys remember when we were doing this before, cosine is always cosine, cosine. Okay? Cosine, cosine. For all the cosines. For a sine identity, it's sine, cosine. Okay? So sine, cosine, minus. So it means it's going to be the sine of s minus t, where s is my first value and t is my second value. So it's going to be the sine of s, which would be 5 pi over 12, minus t, which is pi over 4. Okay, so now we have to put those together. So let's do a little math here. So it's going to be, I'm going to combine like terms here. So it's 20 pi minus 12 pi over 48. So that's going to give me, what's that, 8 pi over 48. And 8 over 48 will reduce. It reduces to something. What does that reduce to? What's 12 times 4? So it's always this times this, then it's this times this, and the sign goes down there, and then these two here multiply together straight across for the bottom. All right, come on, you guys. I'm asking you, what is 8 over 48 reduced to? What is it? 1 over 6? 1 over 6. So now this is going to turn into sine of pi over 6. And pi over 6 is on my unit circle, isn't it? Yes. So sine at pi over 6 is going to be 1/2. Okay, so I'm going to stop right there for today. We'll pick it up. We'll finish the rest of it tomorrow.